All right, here we go. 5-7 video, scatter plots and trend lines. I want to be able to write an equation of a trend line, use a trend line to make a prediction. Stop. You got to hear it all. Listen. All right, cool. Here we go. We can determine whether two sets of numerical data are related by graphing them as ordered pairs. If the two sets of data are related, you may be able to use a line to estimate or predict values. All right, we got a lot of blanks here. A scatterplot is a graph that relates two different sets of data by displaying them as ordered pairs. Most scatterplots are in the first quadrant of the coordinate plane because the data are usually positive numbers. We can use scatterplots to find the trends in the data. A scatterplot below shows three types of relationships. There they are. Okay, let's look at them. In the first one, when the y tends to increase as the x increases, so as x's are getting bigger, as I'm moving to the right, my graph's going up. The y's go up as the x's go up. That's a positive correlation. Here in the second example, as I move to the right, the x's are getting bigger, but the y's are getting smaller. So that would have a negative correlation. And then in that last one, there's really no connection between what's going on. So as I move to the right, sometimes my y's are bigger, sometimes they're smaller. So this one we would say has no correlation. All right. So positive as x's get bigger, y's get bigger. Negative as x's get bigger, y's get smaller. And then no correlation. There's really no trend to that data. All right. So we got to make some scatter plots. So it's very simple as long as we remember how to graph points. First number side to side, second number up and down. Label your axes, all that good stuff. So here we go. So there's the graph. My job is to make a scatter plot. So if I notice the highest altitude is 5,000, all right, so if that's my graph, a reasonable scale from 0 to 5,500, just because I want to get a little bit over 5,000, if I labeled every 1,000 for my altitude. So my graph would look like that. Okay, so I skip the line 1,000, skip a line 2,000, skip a line 3,000. So these are all 500 numbers. Okay, on the other axis, well, what do I see? The biggest number I got to get to is at 61.3. So going up here, I got 1, 2, 3, 4, 5, 6, 7 lines. If I got to get to 61, let's just count by tens, and it'll look like that. All right, you can put every number in there. You can put 10, 20, 30, 40, whatever. I just try to save some space. All right, cool. So now we got them all labeled up. Notice the temperature depends on the altitude. So this is my dependent variable, this is my independent variable. As I get higher, it looks like the temperature is going lower. Okay? Cool. So we're just going to take the points on the graph and we're going to plot them. So for instance, if my first point, just for instance sake, would be 1,500 meters and 55.5 temperature. So that point would wind up right there. All right, so there's 1,500 meters. That's about 55-ish on the scale. Because remember, that's 50, so halfway up, 55-ish, would look like that. Okay? So the other points, if we plotted all those other points, all right, you're probably going to want to pause it here and make sure you have all those points in there. They would go right there. So go ahead, second, pause it, and then once you have the points plotted, come on back. Make sure they're in the right spots. All right, so either look at mine or go off of the table and plot your own. All right, and then when you come back, we'll look at the line. So pause, come back. All right, good. So what type of relationship does it show? Well, as the x's are getting bigger, what's happening to the y's? The temperature outside the plane tends to decrease as the altitude of the plane increases. So the data has a negative correlation. As I move to the right, the points seem to go down. Okay, so we call that a negative correlation. X's are getting bigger, Y's are getting smaller. All right. When two sets of data have a positive or negative correlation, we can use a trend line to show the correlation more clearly. A trend line is a line on the scatter plot drawn near the points that shows a correlation. A trend line is often called a line of best fit because it's the line that best fits the data. All right, so you can see some examples below where the line is going through the data. It doesn't have to hit any of the dots. Sometimes it will, sometimes it won't. All right. should have about the same number on the top and the bottom, but it's just kind of like splitting them. If it runs into some of them, it does, but it doesn't have to touch the dots. Okay, it's just showing you what's generally happening with the data. All right, we can use a trend line to estimate a value between two known data values or to predict a value outside the range of known data values. All right, when we look inside the data, we would call that interpolation. And when we go outside, we call that extrapolation. Okay, so if there was a set of data and then I was going to predict within that range, that would be interpolation. If I was going to go outside of that, we would call it extrapolation. We basically do it the same way. All right, so just a little vocab for you. All right, so here's number 2. Make a scatter plot. What is the approximate weight of a 7-month-old panda? All right, that's something I've always wanted to know. So I got a table there on the left. All right, first thing I'm going to do is make a scatter plot, draw a trend line, estimate the coordinates of 2 points on the line. All right, so here's my graph from my panda. All right, I plotted the points. Again, take a second, go through, plot all those points from the table. All right, okay, there's all my points. Now, when I go to make my trend line, so how do I draw a trend line? Well, an accurate trend line should fit the data closely. There should be about the same number of points above and below the line. Again, you might hit some points, you might not hit any points. Okay, but it should be close to most of the points. It should just fit through the data. And it's a line, so do not try to bend it to hit the lines, the points. Okay, so there's a trend line for me, something like that. Okay, notice I ran into some of the points, but I certainly won't run in all of them. I have about the same number on both sides of the line. Okay, so now I can use any 2 points on the line. They might be from the data. They might just be points that are on the grid that are easy for me to look at. In this case, I see that I hit 2 of the data points. So I know where those points are because I plotted them from the table. So this point is 4, 17.1. And the other point is 8, 37.9. I know that. Now sometimes when you draw your trend line, you'll just have it cross the nice pretty points on the grid, and you can use those numbers. All right? Because once you plot that line and you find those 2 points, you don't care about the dots anymore. All you're going to do is use those 2 points and treat it like earlier problems from like section 5.4 where you had 2 points and you had to draw the line. Okay, so I have the points. Now I need the line. So I need slope. I need one of the points. I'm going to use point slope form, all that good stuff. So slope, remember, subtract the y's on the top, subtract the x's on the bottom. So I just listed my x and y, my other x, my other y, and now I'm going to do slope. Subtract the y's on the top, x's on the bottom, and I get 5.2 for my slope. All right, normally we leave it as a fraction, but in a problem like this, it stands to reason to make it into a decimal. So now I have the slope. I can pick either point to use when I do point slope form. I'm going to pick the first point. Okay, you could have very easily picked the other point. And I'm just going to sub in y1, x1, and the slope. Okay, there they are. And then I'm going to simplify that into slope-intercept form. Okay, so I just distributed the 5.2, add 17.1 to both sides, and y equals 5.2x minus 3.7. Now the question was, what is the approximate weight of a 7-month-old panda? So since x was the age in months, I can just take that 7 and plug it into my equation now. So I got y equals 5.2 times 7 minus 3.7, so y would equal 32.7 pounds. Okay, so the 7-month-old panda weighs about 32.7 pounds. All right, let's see if it works on our picture. So if we go back to our picture with our scatter plot and our trend line, when we go to 7-month-old panda, we would see, ooh, that looks pretty good at 32. Because on this scale, 6, 12, 18, 24, 30, so a little bit above 30, looks like 32.7 is a pretty good number on our trend line. Okay, so that's it for 5.7. All right, I'll see you next time. Peace.